That's my cue. Welcome, everybody. Welcome to the Virtual Night Sky, our version for June 2nd, 2021. We know all the time that we have new visitors, and I want to welcome anybody that's sort of joining us for the first time. This is great. And I know that we have people that have been with us for almost the entire time. We celebrated 1 year anniversary 2 weeks ago. And so we're really looking forward to embarking on our next year of broadcasts. And we have a great program for you tonight. Also, some really great June programming. One of the things is June contains a whole bunch of lunar anniversaries. And so you'll see at each of our programs some science and some presentations about the moon. Tonight is no different, and I'll introduce the team that's going to present from LROC in a moment. But before I do that, let me introduce myself and the team that puts this together. So I'm Rick Alling. I'm the manager of outreach programs at the School of Earth and Space Exploration. This particular presentation is put together by the school at ASU, and we occupy space on the Tempe ASU campus. We started doing this virtual night sky program when the pandemic hit, and we will eventually go back and we will have live programming and we will have visitors come back to our building. But until then, we get together every 2 weeks in our backyards, in our living rooms, together, kind of investigating the night sky as we can. So we've been having a really good time doing this. With me are two other staff members, Meg Hufford and Kim Baptista. Kim is your webmaster. She's the one who's been communicating with you all along, and she's the one that will communicate with you after the program to ask for a survey and get some feedback on what we're doing. We have three absolutely outstanding, amazing students that have also been with us for the entire time. So I'd like to acknowledge working the questions and the polls, and you'll see a presentation from one of them tonight. That's Alex Blanche, Alicia Hyatt, and Spurti Kachere. It just so happens, I don't know if this is a big coincidence or not, but all of them were up in Montana and Wyoming on separate trips within the last 2 years. So they're back, and we'll enjoy when they get there, when they come on. It's going to be a really good program tonight. The first half of it will be exploring the moon through the eyes of the Lunar Reconnaissance orbiting camera and the team that puts that together. Following that, we're going to give you a little update on an upcoming solar eclipse and some night sky programming, and then an update on some things going on and some things we're going to look forward to in the rest of June. So before we go any further, I have a couple of housekeeping things. This is a webinar format, so we don't use the chat, and we encourage you to use the question and answer button. So if something comes along where you like to ask a question, if something that sort of strikes your fancy, you want to know a little bit more about it, go ahead and use that question button and type it in. Also, we close caption. That's kind of important for us, for the recordings and everything, but you can actually toggle that on and off on your own. So if you want to do that, there's a little caption button on the bottom of your screen. You can do that. And then finally, we encourage people to use full screen mode, but you can also adjust some of the settings about how many and who you see on the screen. And we will always spotlight the major speaker. So that's a good way to do it. Okay, now I'm going to turn you over to the meat of the program and the best feature tonight. Let me introduce three people: Nicole Gonzalez, Alex Huft, and Gavin Sundrup. And they are all from the Lunar Reconnaissance Orbiting Camera. This is a facility on the campus of ASU, and it is a facility that operates an ongoing mission, which includes an orbiter that flies around the moon and the suite of instruments, cameras in particular, that take images. And they have a great presentation for you tonight. So I'm going to turn it over to them. Thank you.
Hey, everybody. My name is Gavin Sundrup, and you can see that I'm in a very poorly green screened version of the Apollo 15 lander. This pan was actually taken by James Irwin during the Apollo 15 mission right after EVA-1. But let me tell you about LROC and what we're all about over here. As you can see over in this corner, I'm a multimedia designer for LROC. I do all of the film production stuff, which has been really awesome. LROC, what it stands for, is the Lunar Reconnaissance Orbiter Camera, and we're a part of LRO, launched back in 2009. This is our 12-year anniversary is coming up on the 18th, which is pretty insane. We've been orbiting the moon for a very long time now, And that's kind of a little bit about the team, or about the actual camera and me. And so I think my other team members want to introduce themselves as well before we start really presenting.
Hey guys, my name's Nicole. I have been working with LROC for about 3 years now. I started as an undergrad, and at this point, I'm actually a PhD student focusing on lunar tectonics. But I also specialize in Apollo stuff because, as Gavin mentioned, we do a lot with Apollo data. And I'll hand it over to Alex if you want to introduce yourself.
Hi everyone, I'm Alex. I am a student programmer at LROC, so I do a lot of data analysis behind the scenes. I'm going almost on my second year here at LROC, and I study software engineering as my major.
Gavin, back to you.
All right, let's move on to the next slide. So here's our beautiful moon. In many ways, we've come to scientifically deem that the Earth and all of its inhabitants rely on the moon in some way for survival. The lunar day is 27.3 Earth days, and that's due to its tilt. It only has a tilt of around 1.5 degrees. And the Earth's tilt, to give a little bit of kind of context for it, has a much larger tilt. It's around 27.3 degrees. And then the Earth to the moon is about 384,000 kilometers, which is just a little bit of distance. The gravity is 1/6 of the Earth, which means that everything weighs a little bit less, but its mass, of course, is the same. Let's move on to the next slide. The Earth-Moon system, they both rely on each other in some ways. The formation of the moon may have resulted even by our axial tilt of 3.5 degrees, a little bit off. I'm sorry about that. The moon stabilizes Earth's axial tilt, which means that the Earth doesn't tilt quite as much as other planets that do not have moons. Mars has a tilt of 0 to 60 degrees, which results in its much more versatile environment and climate. So due to the moon, it's very possible that all of our seasons really rely on that. Lunar recession is strengthening or lengthening our day over time, but only by 2 milliseconds every 100 years. So it's nothing too concerning to really worry about, but it's still happening. It's very interesting. We have to take that into account with some of our scientific information. Next slide. The lunar geology basics. The dark areas are mere basalt, and most of them are 2 to 3.8 billion years old, meaning that the moon itself is very, very old as well. Volcanic lavas that erupted on the surface is what left the basalt there. The bright areas are anorthosite, sorry, an ancient crust formed from a magma ocean 4.4 billion years ago. And we've actually had in the past, there's some virtual renderings of the moon and what it looked like with this magma ocean, which is really interesting to check out. A lot of my job is creating virtual renderings of the moon. So just to see what some people have done with simulations to kind of show that magma ocean is also extremely interesting. So if anyone's interested in that, definitely just look it up. Just look up moon magma ocean simulation, and you'll probably find some really interesting things. I highly recommend it. Next slide. The value of the moon, there is a whole lot of interesting components of the moon that we like to look into. There's a lot of different components of it that display different information about the Earth as well. Just on Apollo 15, there was a green boulder that was found, which was one of the oldest samples of the Earth that we've actually ever found on the moon. So it's very interesting to just kind of see just different samples, and learning about the formation of the moon in many ways helps us learn about the formation of the Earth. It's a great testing bed for leaving the planet Earth because, one, it doesn't have any atmosphere, so launching rockets off of it is a lot better, and being stuck only 400,000 kilometers away from the Earth is a lot better if something goes wrong, even more so than that. Next slide.
So of course, to do any of the work that we have been doing, we need the spacecraft. So here's a diagram of the Lunar Reconnaissance Orbiter that was launched back in 2009. Really what we use a lot of are the you can see on the left side, it says LROC NACS, which stands for narrow angle cameras. So there's 2 of those, which is important for something we'll talk about very soon. And LOLA, which is a laser altimeter, which gives us very precise data of how far away the ground is. And the LROC WAC, which stands for wide angle camera, which is useful for taking larger pictures. Next slide, please. So just a little bit more about the NAC. So these are very nice cameras. You can see there's a whole bunch of data on these, but what's really important is these give us extremely high resolution. So when we're in a 50-kilometer orbit, we can get about 0.5 meter per pixel, which is really great. And we have 2 of those as well. So we can get a 5-kilometer swath of land at the same time, which is really cool. Next slide. And then the WACs, which have a very much lower resolution, which is about 100 meters per pixel at a 50-kilometer orbit. But these are very useful for just taking general images of an area. Next slide. So one of the biggest things that LROC does is create digital terrain maps. So these are so we use the NACS, which I mentioned before, and the laser altimeter, which I also mentioned, to create essentially 3-dimensional elevation data of an area. And this is really useful because if you just look at a flat image and don't have any sort of data go with it, you wouldn't know where elevation. So here's you have a flat image on top, and then we would process that into what you see on the bottom, which we call a color shaded map. So you can see that the land is actually sloping up to the left, which is cool, which you couldn't tell in the flat one. All right, next slide. Now, this is done with the 2 NACs. So the reason that there's 2 of them, are other than just being able to take more images, is that because they're slightly offset, we can get a parallax between them. And if you're not familiar with that, it's like how your eyes work. So if you close one eye, you won't have any depth perception, but if you have both eyes open, you will have depth perception because of the way you can see images moving around when you like move your head and stuff. That's actually the same sort of process we use. So these images look really, really similar, but I promise there's about 100-meter difference between them, which is only about 10 pixels between the images. But that's just enough difference between the 2 images that we can actually start extrapolating elevation data out of it. Next slide. So here's sort of some visuals on it. So if you see that little, like those boxes on the left, you can think of one image as taken a first time in an orbit and a second image is taken in another orbit. So there's essentially 4 images that can get combined. And you can see with that other diagram on the right, with the satellite offset, we get a really nice picture of the same area. And then we can use that parallax, the parallax of the images to create a 3-dimensional map, which is how we get the bottom image. Next slide. So recently, the KPLO, which is a Korean-built spacecraft, will be launching soon. And what's really neat about this is it contains shadow cam, which is, I believe, is the next slide. And shadow cam is like the NACS. You can see it actually is practically the same exact layout as the NACS, but it has a different sensor in it, which is 200 times better, or 200 times more sensitive than the NAC. So that's really useful for seeing the poles of the moon, which are usually covered in shadows most of the time. And we can use this to actually look into shadows, interestingly enough. Next slide.
All right. And as much as we love to look at the future, we also sometimes need to look at the past in order to learn from the lessons that we have come across before so that we don't end up reinventing the wheel when we revisit the moon or when we return to the moon with Artemis. And where better to do that than by looking back at the Apollo missions. So this in particular site is the Apollo 11 moon landing. So the very first time humans ever set foot on the moon. And this is what it looked like on the left over here during that mission. So we're looking at a camera that's inside the spacecraft here. And on the right over here is what it looks like in our NAC images. You can see up in the upper right, if you're looking for reference where that is on the moon, that's where they landed. But here on the right, this is what we can see with our NAC imagery, so our close-up camera. And you'll notice right away, you can see a few glints here from some of the equipment that they left behind. In particular, this piece of Lunar Module, and we'll get back to that in a second, but you can also see these kind of dark trails left across the moon surface there, and that's actually their footprints. So we can see their footprints in our NAC imagery. Just for comparison, you can see they were kicking up some dark material here on the left. And that's what we see on the right in the NAC images. So I mentioned I was going to tell you a little bit more about that lunar module. This is what it looked like on the left over here during the Apollo missions. This photo was taken by an astronaut when they were standing outside the spacecraft. And what we see here is the top part is actually where the astronauts would live and work while they were on the moon. Not while they were outside it, obviously, but that's called the ascent stage. And this bottom part here wrapped in gold foil, that's called the descent stage. And that contained all the fuel tanks and the scientific equipment bays and things that they would deploy while on the moon. And because of that, by the time they wanted to leave the moon, this part was virtually empty. So they left it behind so that, as we mentioned, you always want the lightest spacecraft to leave a planet. So they would just take this ascent stage and leave with that. And this descent stage remains on the moon today. And that's actually what we can see in our NAC imagery here on the right. See it shows up really nice and well because of that gold foil. So it's incredible that we can see so much detail of it. And before I show you this video real quick, I'm going to give you a little bit of background here. So this is the Apollo 12 landing site, and you'll see that lunar module that we were just talking about right here. You'll also see some of the equipment that we mentioned before that the Apollo astronauts deployed, and Surveyor 3. Now, Surveyor 3 is a robotic spacecraft that was actually sent there about 2 years before Apollo 12 landed, and they wanted to come and visit it to see if they could land pretty close to it, and they were able to. But this video in particular is going to focus on what it looks like during one day on the moon. Now, keeping in mind one day here being sunrise to sunset, but on Earth, that only lasts about 12 hours, but on the moon, one day from sunrise to sunset, because the same side of the moon is always facing Earth, is equivalent to 14 Earth days. So let's see how the light changes while looking at the moon over the course of 14 Earth days, or one lunar day. You can see a lot of different features on the moon become a lot brighter at different times. You can see the equipment become a lot more reflective. And then towards the end of the day here, you can start to see some of the terrain become a lot more prominent. I go one too far forward. There you go. And over to you, Gavin.
Awesome. So this is actually the Luna 17 point. That's the Lunokhod 1 rover right there. This is a Russian sent rover to the moon, and it's actually was sent in the year 1970. So it's just a touch old. It was actually placed on the moon with retroreflectors, which were thought to have been lost until 2010, when our team of photographers with LROC were actually able to capture where the rover landed and where it ended up in the end. And we were also able to give a distance within a few hundred meters instead of where scientists were looking at the time, which was within a few miles of radius. So you can see it right there. We actually have a very clean image of the rover itself. And this is one of 5 of retroreflectors on the moon that are still used. How these work is that we have planetariums and observatory stations that shoot laser beams, and they pretty much reflect off of these retroreflectors, hence the name, and they send back information about the rotation and movement of the moon, which we can then use for coordinates, which are still used all of the time, as well as lots of other information about flat Earth surfaces. Next slide.
So the permanently shadowed regions. So this is what ShadowCam is looking into. So what you're seeing in this image is, it's called a ratio map. So the light is places that are in the daytime or in the light more of the time, and the dark places, and particularly the completely black spaces, are where light never actually touches. So that's why we're building shadow cam, is to actually see into these completely dark spaces, because they're cool and we want to see them, and they're very cold. So we don't know exactly what they could hold. A lot suggests that it could be water ice frozen down in these permanently shadowed regions.
All right, the impact craters dominate the lunar landscape, and they're a cause of hypervelocity impacts of up to 16 kilometers per second, which is quite fast for crater impacts. Tycho crater is one of the most famous, and it's easily seen with a small telescope or binoculars, but of course our imaging software is much better, so we can get a really close-up image of it, as you can see right here. There are even 3D models of it that we have displayed on both of our websites and several image galleries. There's a closer photo of it, and if you look at the very, very top of it, there's this little boulder. And while the depth that we have here, it's hard to get context, that boulder, for reference, is about the size of Sun Devil Stadium. So that is a massive crater with a massive hill in the middle. Next slide. All right, we're going to play a little bit of crater name trivia. So basically what we've got going on is the next slide is going to have 4 different craters. 3 of these craters will be properly named, and one of them has a false name that I made up. We're going to start a little poll here so that you guys can try to guess which one has the made up name, and see how good your crater name guessing skills are. Just going to let a few moments pass by for you to guess. All of these images here are taken from our LROC cameras and are available on our website, as well as you are able to actually take a closer look at this with QuickMap, which is a software we will display later on in the presentation. It's quite amazing how close up you can get. Most of these craters are within 12 kilometers, that top left one, and the bottom right one is actually 18 kilometers wide. All right, I believe voting is slowly slowing down, so let's give a few more seconds. 5, 4, 3, 2, 1, and let's reveal. All right, so most people think that the fake name is Boss. Let's go ahead and see if that is the case in the next slide. All right, so Dog was actually the fake one, and its real name is Fox. The Fox crater is named after a very famous astronomer called Philip Fox, and he actually was the first director of the Adler Planetarium in Chicago. And while many people may not have heard of this planetarium, it was the first planetarium in the Western Hemisphere. So it is a very substantial and important prominent figure, and he is now got a crater named after him. This crater is about 12 kilometers wide and is on the far side of the moon. All right, here are some lunar pits. Pre-2009, we only had speculation that there were lunar pits on the moon, but we weren't positive about them. And then later, in 2009, 3 pits were discovered in Selene images. In 2010 through 2014, our team LROC have been finding lots of images of them, revealing 5 more Mar pits, made up of about 200 impact melt pits and 2 apparent highland ponds, or highland pits, sorry. Highland ponds is a different area of the moon, which is very interesting. This bottom left pit here is got a very good image for us to look at. It's about I believe most of these pits tend to be around 10 to 20 kilometers or 10 to 20 meters down, which is about 30 feet. They give us a really good view of how old the lunar surface is. It allows for easy extraction of samples since it's already got a pit. It's very difficult for any teams to actually be able to drill down deep as soon as they get on the moon. In Apollo 15, we actually used drills for the first time up there, lunar surface drills, and they were made up of these nitrogen-filled pipes, and most of them actually broke on the surface. And while this was the first test, we've still had difficulties drilling. So these lunar pits allow for really easy sample collection, which is important for learning about how the crusts were actually developed, which gives us a whole lot of information about the moon's development, as well as possibly even our own planet. These pits also will allow for really good cover for astronauts if we have longer stays on the moon later on. If habitats are to be made, it's likely we will be using these pits, and our team has gotten some of the best images and some of the best information about them. So just going forward for future moon missions, these are going to be very, very helpful details for us to utilize. Next slide.
So,
All right. Oh, you go ahead. Sorry.
So a lot of people ask about if we can see meteors hitting the surface, and the answer is yes. So a lot of times if we take an image in the same place, we will search through that image to find any differences. And you can see this little GIF on the left side of this is two images, one just taken later than the other, and you can see very clearly that a meteor struck the surface and created those nice rays. And then on the right side, that's essentially a difference map. So we can take these two images and find what's the same and find what's different. And that gives you a really nice idea of how big this meteor was and how much it spread across the surface.
Alrighty, and we've mentioned QuickMap a few times now, so I'm going to go ahead and give you guys a quick tour of QuickMap. This is a software that you can use yourself. It's online, so you don't have to download anything, and it's made using LROC imagery. So what we're seeing right now is a mosaic of wide-angle camera images to create, well, to see what we see from Earth every day. And this is this is the side of the moon that we see all the time, the near side, as we've mentioned, the other side of the moon being the far side, not the dark side, as Pink Floyd may have you believe. But anyways, so we've got here on the left, actually, I'm going to switch it to 3D mode here so that I can control where we view a little bit better. And I'm going to try and give you guys a tour as we go through this, kind of generally how to use it. So I'm going to switch over to layers here and open this overlays tab. And just to start us out, since we've been talking so much about the LROC spacecraft, well, the LRO spacecraft that carries LROC, this orbit, this yellow line here is the orbit of the spacecraft. And let's actually drop down and take a look at what she's flying over right now. So this is the spacecraft, and it gives you a pretty live view of what she's passing over as we go through, which is a pretty darn cool thing. That being said, it is pretty intensive and zoom tends not to play nice. So I'm going to go ahead and turn that layer off really quick and use up here in the upper right. This is the home button. So this returns us to that view of what we're used to seeing of the moon from Earth every day. Again, because we have the same side of the moon is always visible to Earth. All right, so I'm going to bring us to a pretty cool feature here that we like to look at. I'm going to turn on this nomenclature layer, and nomenclature is really just a fancy way to say all the named features on the moon. And that does kind of clutter the screen a little bit. So I'm going to focus on one particular feature here called Vitello. And Vitello was named after an Italian scientist in the 13th century, I believe, which is pretty darn cool. But I could click on the word Vitello here and it would bring us right to the crater. But since I actually know where it is, I'm going to go ahead and zoom us in so we get a little bit more of an interesting view here. And since that nomenclature, I'll go ahead and turn off the nomenclature layer there. But this small circle over here is called Mare Humorum. And Vitello Crater is actually on the edge of that. We're going to start to be able to see it here pretty quickly. This is Vitello Crater right here. I'm going to keep zooming in a little bit so that we can get a little closer and have a nice view of it. Bring it to center. All right, so this is Vitello Crater, and it's a pretty cool crater. You can see it's got what we call a central peak here, and that means that there's been a little bit of uplift before it cooled completely. And that created a little peak here in the center. It's kind of like a little mountain, but it also has this kind of ring of fractures around it. And because of that, this crater is actually classified as a floor fractured crater. And that indicates that there may be some volcanic activity or something like of that nature going on that uplifted the center here a little bit and kind of started to crack the surface. So that's one of the ways we can tell a little bit of what's going on in the subsurface is if there's indicators like that. And the moon may still be volcanically active. So it'd be interesting to see if something like that could indicate that. That's one of the things we've been studying. I'm going to also bring us down here a little bit towards this kind of odd line cutting through the terrain here. Now, this is a tectonic feature. There's lots of features like this on the moon, but until we took the LROC images with LROC, we weren't able to see that many of them. I'm just going to kind of keep zooming into this layer here, kind of towards this bright crater here. The brightness of this crater actually indicates that it is a fairly fresh, recent crater. And by recent, I mean geologically recent, not in human history. So recent on the moon can actually be classified as up to the last billion years of Earth's history. That's the last quarter of the moon's history. So not all that recent for us, but recent for the moon. And as we zoom in here, you can kind of see we're starting to get towards the end of the wide angle camera resolution, but what just popped on there was the narrow angle camera images. And this crater kind of starts to get a little bright. So I'm going to zoom into this feature down below it over here a little bit. This is a tiny little crater. I don't think it has a name, but it's been squished actually by this feature over here. And I mentioned this is a tectonic feature. This type of feature we call a lobate scarp. And what we mean by that is that the blocks of the moon's crust have actually kind of shifted a little bit, and one side kind of relative to the other has popped up a little bit and ended up kind of giving it this jagged appearance. I'll show you what I mean by that. If I drop us down, this is the beautiful thing about having 3D mode here, is I can drop us into the terrain a little bit. Whoop. A little too close there to be zooming in. Whoop, too far. There we go. What you can see at the left here is raised a little bit relative to the right-hand side. And that's kind of what indicates that this is a scarp. And the lobate part of that name really just meaning that it kind of wanders around and has kind of a weaving nature to it. And you can kind of see that there from that angle. But as I zoom in, this is that kind of squished crater that we were looking at here. You can really start to see some of the resolution, the incredible resolution of our NAC imagery. Now, these boulders, for reference, are probably about the size of a house. So not small, and pretty incredible that we can see them so clearly here. I'm actually going to zoom us down, just bring us along the fault line here and bring us to another site. This is another cluster of boulders here along this fault scarp. And if a fault scarp has enough of these clusters of boulders, it actually, recent theories suggest that this could be an indicator that this fault line was active geologically recently. Now, by that, again, I mean several within the last few 100 million years. So that could be 500 million years ago. But it is something that we are looking into right now actively to see if boulders could indicate that. But there you go. So that's some cool features on the moon. I'm going to go back to home view here. Just a quick view of how to look around. Oh, and to navigate, you can scroll to zoom in and click the mouse wheel to rotate when you want to look around at a feature. But there you go. A little bit of quick map and some interesting features on the moon. I'll hand it back to you now, Rick.
All right. Hey, thank you guys so much. I'm always amazed at what you guys are turning out, and the fact that I think this might be lost on some people, but at ASU and your center there, they're actually driving this machine, right? So the thing is orbiting, but they have the capacity to just kind of tilt a little bit and organize a little bit. And so as they're making subsequent passes over and over and over the moon over a long time, they're getting just every little angle they possibly can of all these other things. And that's how over years and years and years building up this data, they can come up with these amazing 3D images that we're seeing. And I encourage anybody to go look at that quick map. It doesn't take a download. If I understand right, all you really do, it's a website. So if you've got a good, strong internet, just go and learn how to fly that. I've spent hours and hours and hours on different planets with different kinds of things here, just cruising over the surface, just not looking for anything in particular, but you're just gonna just move a little bit and kind of watch the surface go below you. You're flying over real data. I mean, this is not an artist's conception of what's going on the moon. This is actually the real thing, and we get to actually fly it now. And I just think that's amazing. The other thing I wanted to mention about LROC is, let me see, I guess Gavin said that it's now 12 years, right? And this is something that happens to us in missions often, that they actually have a life, right? So there's a mission objective that's usually about 18 months. It varies per mission and all this stuff. So they're going to get it up there. They have a role. They're going to get these goals. 18 months later, if they've got there, they've accomplished it. And this particular spacecraft has just been going and going and going. So they re-up the mission. They go back for more funding. They say, we're still turning in data. It's still valuable. We're still there. We're still going through there. And this is a really, really good example of a well-built spacecraft with a real simple mission that is just, I don't know, does it have a life? I guess it'll probably have to end someday, but Nicole, do you know? Is there a time
little bit.
It absolutely has to die? So.
Well, until we have another spacecraft to replace it, we really want to keep this one going as long as we possibly can, because the data that we bring back was really, originally, this was a part of a constellation mission. And the goal of those was to, be to return to the moon with the next manned missions. And now that we are starting to actually do that with Artemis, we really need to keep the spacecraft relevant and make sure that all the data that we churn out is useful to that. And we've been doing a pretty cool job with that, I think. We've got a lot of amazing results for Artemis and all that. And I think we are on our 4th extended mission now, almost into our 5th. So we've re-upped the life of the spacecraft significantly.
It also means that you have a really good quality program, right? You're recognized for what you're turning out. So it's worth refunding and re-upping as we go along. I think that some people don't realize that these missions just, they have a life and then they can keep going afterwards. I'm going to ask a personal question of Gavin and Alex. Okay, so how old are you?
I am 19.
Alex?
I am 20.
20. And so basically this spacecraft launched when you guys were like 9 and 10 years old. When did you, so it's up there, right? You're going through grade school and high school, and you end up in college. When did you sort of like learn about the LRO and LROC and the mission? What drove you over there? How did?
I'm embarrassed to say I actually didn't hit the mission until about a year ago when I started at ASU. I was wandering around the campus a bit, just kind of trying to check out what I could safely with masks and of course, just kind of seeing what was offered and what buildings were around. And I saw the Interplanetary B, I believe we are, building with the moon signs and all of the images. And I just kind of walked through quickly. And I realized later that there was a job listing for a multimedia design position there. And since that's what I'm doing is filmmaking practices at ASU with plans to go into film and media production, that was totally right up my alley, and it has been amazing. And to just quickly go off of the last question as well, based off of some estimations of fuel, the LRO spacecraft is speculated to live about 5 to 7 more years with fuel. However, due to its orbit, it could easily still float around for quite a bit longer before actually eventually crashing. So we still have a good solid bit of life in there.
That's excellent. So Alex, so how did you join LROC? How did you find out about it?
I'm actually worse than Gavin in that respect. I didn't even know it existed till I heard there was a job opening and I applied. And then I actually learned all about it. So yeah, I didn't actually know till I applied for the job.
Right. And generations of students like coming and going. And stuff. Okay, Nicole, I guess I can't leave you out. So what made you interested in Moon and that program?
Oh, I've been fascinated by the moon since I was in middle school, I think. It was when I started learning about the Apollo missions and I was hooked. There was no going back at that point. How I found out about LROC, I think it was going to presentations like this once I came to ASU, and I actually learned that we had access to a satellite and a team that worked on it on ASU campus. And it was kind of like, well, I have to be a part of that. So I applied for it. Yeah, and at this point, doing my PhD through it. So there you go.
So I think I remember this. So you did finish your undergrad and then you turned around and came back and stayed. And so now you're.
I did, yeah. Just too much fun.
Absolutely excellent. And for our audience, it used to be, of course, that younger students, undergrads, would never work in a program like You'd have to have a master's, you'd have to have experience, you'd have to sort of have some, but at ASU, we've got so many missions and so many opportunities and so many professors that are willing to bring people in at these younger ages. I think it's amazing. And then Gavin mentioned it, that there is actually a facility on campus. So when we reopen and people can come back and visit and all this stuff, the building that I'm in is on the eastern part of campus, and on more of the central and western part of campus is a building called the Interdisciplinary Being. And there is a little display area. You can look into their little mission control area. There's some devices to look at, some amazing photography in the hallways, and a lunar rock, actually an actual sample from the moon that came back on one of the Apollo missions is actually in there. So I encourage everybody to look at that. Okay, it is time to turn it over now to Alicia, who's going to kind of just run us through some polls and some questions. I was supposed to remind you, and I'm sorry I didn't, but if you have any questions at all, now's a good time to get them into the question and answer queue. If you want sort of like something personally answered, and especially if it relates to the moon and LROC, this is a good time to ask those questions. So Alicia, off you go.
Thank you so much. Yes, please type your questions in our Q&A. But I'm going to go ahead and launch our first poll. And so that is, did you view the lunar eclipse on May 26th? Yes or no? And then if you did, either way, where are you viewing from tonight? So Arizona, outside of Arizona, but still in the United States, or outside of the United States. So go ahead and cast your votes, please. And with that, I'm going to hand it to Alex to take some questions.
Yes, we got some good questions for the LROC team. The first comes from Natalie. She asks, has there been any advances in the camera being used since first used in 2009, or has it stayed the same?
That is a good question. Gavin, you might be the most well-equipped to answer that one.
Yeah, so we are not actually able to physically work with the spacecraft, of course, as it orbits the moon. So the camera physical systems have not changed. However, we have developed several AI technologies that actually scan image to image to look for differences. Alex was Alex Huft was mentioning that earlier in the presentation with showing the image before and after another crater had formed. And so even though the actual physical camera doesn't change, our technology and ability to use it does. We're coming up with new softwares, new programs for using DTMs to get better 3D information. And just the ways that we're able to use the information and the camera itself is becoming better. The Kodak system for how it sends information to us can be received either faster or with stronger power than it was in 2009. So of course, while the actual systems have not changed, the quality has, because of our ability to work with it and the software changes.
Excellent.
I hope that answers it.
Yeah.
Okay, and then this was kind of already answered in chat, but I'm curious to get another perspective as well. Howard asked, I'm sure this is referring to the surface brightness and color. Why does brighter indicate more recent?
That is a good question. That has to do more with space weathering. Here, we don't see that as much on Earth because we do have an atmosphere that shields the Earth from the effects of radiation that comes from, the sun, from other stars around us. And I don't have an exact answer for that, but we think it has to do with how the light changes, or the radiation really, and the effects of the weathering of particles that hit the moon's surface actually change kind of what's going on at the surface there. So when an impact like Tycho or the one that I was showing you over by Vitello Crater, when that hits the moon's surface, it actually uncovers the stuff that has been buried for a long time. So it hasn't been exposed to that space weathering. So the darkness is what you see kind of as a effective space weathering, and the light means that it has been recently exposed.
That's a good answer. Sounds good to me. In fact, and we can see that those major streaks, right, that come out of an impact and they sort of trail across the moon for some of them, like in Tycho, it's like a quarter of the moon's surface is streaked by one impact. So.
Yes, it does. Those are called rays. And yeah, they're really handy, and they go really far because the moon is so much less mass than the Earth.
And you can study them. I think it's amazing.
Indeed.
Who wants to wrap up this poll? I am so proud of 57 of you that got up in the middle of the night and went out and looked at that lunar eclipse. I was out there with you, and I applaud your verve to go there. I think everybody, anybody that saw it, and it probably realizes it was a little bit cloudy. I got up about 3:30 and I saw the clouds and all that stuff. And I elected not to go through the process of setting up a big camera setup and all that stuff. But I did go out about every 15 minutes and watch the progress, see what was going on. And with the clouds, with the coloration on the moon, it was really spooky looking. I mean, it's a memory I will have for a long time. It's just the way the clouds interacted with the colors and the bright limb and the dark spots and the reddish hue in some of the moon. It was really very, very beautiful. Nicole, did you go out and look at it?
I wish. I'm actually out in San Diego where it was too cloudy to even see it. So I wasn't able to see it.
Okay, back to Alicia.
Rick, you kind of answered it. So number one, most of us did not go outside, but the 57 of us that did, wonderful. We're so happy that you went out and enjoyed that event. And then the second one is, where are you viewing from? And most of us at 71% are viewing from Arizona. So we're happy to have you no matter where you are. But yes, happy you're joining us tonight. So with that being said, I'm gonna give it back to Rick, who can carry on our show. So thank you.
Thank you very much. We have a little feature we like to do. You guys have probably seen this before, but we're following the progress of some of the planets. And so I think if you've seen this before, I've got a little live view of the solar system. I'll kind of move out a little bit so you can see those inner rings are the inner rocky planets. The red one is Mars, the blue one is Earth and Venus and Mercury next to the sun. I'm going to just blow up these planets a little bit. So we had this little argument before the show. Is it okay to blow up the planets and take them out of scale? I'm saying it is, because you got to see what's going on here. And then I'm going to position ourselves so that we're kind of looking across the surface of the Earth towards the sun. And what you're going to see here, you can sort of see that from this view, is this is the planet Mercury, this is the planet Venus, and here's the planet Mars. And so they're all in a row right here, and here's the sun. If I can do this, let me just sort of like roll up. You can imagine that this is sort of how we see the planets in the sky, because the sun goes below the horizon, orbit a little bit, so you can see, and then we get to see those planets above the horizon. Last thing I wanted to show you in this particular view as we're looking at this is, in the last 2 weeks, Mars and Venus have traded places. I'm sorry, Mercury and Venus have traded places. So Mercury used to be on the other side of Venus, and Venus was over here a little bit. And then watch this. So Venus is moving in this direction, right, away from the sun. Mercury is moving this direction towards the sun. And you'll see in a little view I have of tonight's sky, I think it's kind of the last chance you'll be able to see Mercury before it passes into the sun. It'll become a morning object in about 2 to 3 weeks. And so we're about to lose it in the evening sky. But then just remember these positions. Then one more thing before we go. I'm just going to show you, let's see, how do I get this particular view? I'm just going to change something real quick here. Sorry, I have to sort of center different things as we go. And I'm going to orbit up a little bit. Oh, that's orbit up a little bit and then over. And I want to sort of show you the Earth's view of Mars. You can see Mars in the distance over there. And then these two stars right up here. This is Castor and Pollux. Those are the twin stars, right? The stars of the zodiac constellation Gemini. Castor is the one on this side, Pollux is the one on this side, and then Mars is right down below it. So now I'm going to go back and land on Earth, and let's see what all this means to Earthlings. I'm going to restore the size of the planets, because people would get very angry if I left them large like that, large and in charge. Well, let me spin down here. I'm going to kind of rotate the dome a little bit. Watch this. I'm going to load a little panorama. If you've kind of watched our program before, you know I kind of love the western part of the sky, because I get to see what's going on there. And there's the house across the street. And here's what we got. So here's Castor, here's Pollux, and here's Mars. Remember, we saw it in space and its relationship to its orbit. We make Mars just a tiny bit bigger. So it's a little bit more prominent in this particular view. There you go. And so right here, this is Castor and Pollux, the twins, and here's Mars. And the other night I was out walking Luna and we were kind of out a little bit later and I saw that and it just reminded me of the arc of the handle of the Big Dipper. So tonight, here's your assignment. After the program tonight, I'm going to kind of close out and we'll let you go outside, look towards the west, look at this sort of the relationship between Mars, Castor, Pollux, and Mars. Very, very easy to find. This is another big, huge, bright star called Procyon. And but this will be easy to see. And then look kind of straight up and over towards the north and look at the Big Dipper. And you'll see the handle and you'll see this. Now, one more thing, and then I'm going to turn it over to Alex to tell you about a solar eclipse, but I'm going to go forward a couple of days. Watch what happens to Mars and Venus. I'm just going to advance. Here's 1 day. Here's 2 days. 3 days. So here I am on Sunday this week. And now look what's going on, right? Mars has moved enough so that it's almost in a straight line with Castor and Pollux. So this is really sort of fun because you can go out every single night and you can watch this progression. Just go check it out. 8 o'clock every night, look at the same part of the sky. You'll identify all the players, but you'll see that there's a slight difference. There's a slight movement of this planet and changing its juxtaposition with Castor and Pollux. And I think that would be really, really cool for you guys to check out. Okay, that's your night sky view tonight. And we'll turn it over to Alex because there's a solar eclipse coming up. Alex, are we going to be able to see it?
No, unfortunately not, Rick.
Oh, no.
Well, I guess unless some of you are crazy travelers, then maybe. But let me share a resource to show you guys what this is going to look like real quick. So actually, some of you that might have caught our show, the last show, we actually showed a resource called timeanddate.com. This is a great resource for really a lot of things, you know, world clocks, time zones, weather, but also it's great for eclipses. So if you go to the main timeanddate.com and you look at sun and moon, you can go right down here to eclipses. And then actually you can see a list of the lunar eclipses that you can see. So this one, the June 10th, this is the annular solar eclipse. And as you can kind of see if we go, so this is what it's going to look like at its peak. You got a lot of resources, you got a countdown. But if we look at this map, you can see that really, unless you're in a very specific area of part of North America and the United States, you're really not going to be able to see much. You might be able to see.
So the white part is invisible to the thing. So all of Western America and where we are.
So this kind of heat map, these yellows and then reds. The dark red is where you can see the full annular eclipse, and then the varying levels are where you can see partial annular eclipses. So if you're in the northeastern United States, you can see a partial. I can't tell if that area is really so if you're in this very, very top corner, you might be able to see it.
Oh, that's Thunder Bay. People know Michigan.
Yeah, so if you're in that very top corner, you might be able to see the total. But for the most part, if you're in the majority of the United States, you won't be able to see this annular eclipse. Now, annular being that it's not, the moon doesn't completely block out the sun still kind of peeks out a little bit around the edges. But you can see that this won't be a solar eclipse that we'll be able to see the total portion here in Arizona and for most of the United States. But this is just kind of an extension of the resource that we talked about a little bit last week. If you're looking for eclipses that you can see, timeanddate.com is a great resource. But this one, unless you're in maybe in another country, or if you're in that very small sliver, you won't be able to see the full thing.
Okay, it'll happen again someday. I also wanted to point out to people that eclipses actually kind of often happen in pairs. So last week, remember, we showed you all the conditions that have to exist for the moon and the sun and the earth to be in a straight line. Well, those conditions kind of last for a little while. So it's not unusual to have a lunar and a solar, or a solar and a lunar, and it's not that unusual. And too bad we can't see this one. There's one coming up in 2025 that is a total, and it covers a lot of the United States, Texas up into the Northeast. And so we'll be looking forward to that one. Thank you, Alex. And so I'm going to turn back over another poll question if we have time. And Alicia wants to tell us about some current events coming up.
Oh, I guess,
Actually, Rick, I don't think we have another poll question.
Sorry about that.
That's all right. That's okay. I think we're just going to hop right into current events if that's all right.
Okay, perfect.
Awesome. So I'm just going to share my screen.
And I see on my notes here, no second poll. So, okay.
That's all right.
I just have to read my notes.
That's all right. So this week's current events, we actually have several to talk about. So I'm going to try and get through them kind of briefly. So just today, NASA has selected 2 missions, and they're both going to Venus. And this is the first time this has happened in over 30 years. So we're very excited, and even more excitement to be had at ASU on this mission, or on one of the missions, Da Vinci Plus. We have our very own doctor from the School of Earth and Space Exploration, Dr. Mikhail Zolotov, who is a planetary geochemist and is a co-investigator on this Da Vinci Plus mission. So we're very excited here at ASU to learn more about this upcoming mission and everything that it has to offer. And then of course, we're also excited about the Veritas mission and all the science that we will receive from that as well. But again, we have an ASU representative for the Da Vinci Plus mission that we're very excited about. Continuing on, we have a special event, the Interplanetary Initiative. So this is a webinar happening on the 17th of June, and it is titled Why We Go, Social Futures of Humanity as an Interplanetary Species. And it's going to be given, or the conversation will be led by Dr. Lindy Elkins-Tanton of the ASU Interplanetary Initiative. And this is going to touch on the social side of deep space missions and deep space exploration. And like I said, that is on June 17th. And we will have information about both those missions, about both those missions in the chat. And we will also have the link to this webinar in the chat as well. Continuing on, we have the Arizona Historical Society Space Exhibit. It opened on May 20th down in Tucson. And so there's several ASU space exploration items there. And it is called Ready to Launch, Arizona's Place in Space. So it's running through November, and we highly encourage you to take advantage and go and check out what the Arizona Historical Society Space Exhibit has to offer. And finally, we have our resource of the week. Thank you so much to LROC, to our wonderful presenters, Nicole, Gavin, Alex. And so they brought our resource of the week to us, and that is going to be Quick Map. And we will leave the link to Quick Map in the chat as well. So make sure you check out that resource and you get to know the moon and get to know its craters as well. So thank you so much for listening to this week's current events. And Rick, I'm going to pass it back to you.
This is great. Hey, you guys realize that we've actually got a lot of stuff in this program. It was packed with information, and we can still close within the hour. So I think we're doing pretty good. I just want to give everybody, again, a big thank you for staying with us and participating. I hope these are of interest to you. You can tell if you've been around a while, we have a tremendous amount of variety. We go from missions to night sky, to some sort of sometimes mythology and ancient cultures and how they view the night sky. We have a wide variety of things. I know people love astrophotography, so think about one of those in July. But we actually have 3 programs in June. Just the way this works out, it's every other week, but it happens to be one today and one at the end of the month and then one in the middle. So in 2 weeks, we're going to be celebrating the solstice. So solstice will be coming in just about 4 days after our meeting in 2 weeks. And our program will be all things solar. I'm going to introduce you to a brand new professor at ASU, Professor Christina Bossart. Sorry about that. I kind of lost her name in the moment. Katrina Bossart. And she is a researcher. She actually sort of researches the effect of solar radiation on the upper atmosphere. So she kind of considers herself an atmosphere scientist, which is really cool. And she knows an awful lot about the sun. So the science we're going to be listening to is solar next week, and in celebration of the winter solstice. We also, because June is lunar month, we will have another visit from LROC. It won't be the big 30-minute presentation, but we're going to show you some new resource from LROC as well towards the end of that program. And then finally, we're really looking forward to the end of the month. June 30th is going to be the date. That's our last virtual Night Sky program in June. And we've got a really special treat for you. ASU has a tremendous collection of meteorites and a meteorite center that is world renowned for the study and the research that we do in meteoritics. And so you guys get an amazing tour of our meteorite vault. The guest will be Lawrence Garvey. He's the curator of that collection. And we're going to spend most of the hour basically touring the vault and learning the secrets from all the meteorites that are in there. It's an amazing experience. Most people never get a chance to do this. So we're really looking forward to Lawrence Garvey and his presentation there. So keep coming back. I really enjoy hearing from you guys afterwards. Please, Kim will be sending you out a little thank you and survey. We use those surveys. We learn from them and we use them to organize kind of making our programs better and responding to your questions and some of the things you want to see. So thank you very much for my guests tonight, Nicole, Alex, and Gavin. Thank you very much. And thank you very much for the team to hold this together. And with that, I'm going to say goodnight and look at the night sky and see what you can see. See you guys later.